Hello students. Hello and welcome to this video. In this video, we will solve question number 251 to 260. The link to download the PDFs will be in description. At the end, I will show you how you can download and maintain updated copy of the PDFs. As well as I will show you my website where you can come and join my community where we can ask and answer questions through my question answer web application and grow the community and learn from each other. So without further ado, let's get started. Question 251 says that sum the series 1 plus 1 upon 4 plus 1 times 3 upon 4 times 8 plus 1 times 3 times 5 upon 4 times 8.12 up to infinity. So we have the formula for 1 plus x to the power n, and then we equate nx is equal to 1 upon 4 and n times n minus 1 upon 2 factorial times x square is equal to 1.1 times 3 upon 4 times 4. Now we square this and we divide. So we get n square x square upon n times n minus 1 times 2 factorial upon x square is equal to 1 upon 16 times 4 times 8 upon 1 times 3. Which is equal to 2 by 3. Now x square will get cancelled, that is why we squared it, and we will be left with 1 upon n minus 1 is equal to 2 upon 3, which gives us n is equal to minus half, which gives us x is equal to minus half. So the series becomes 1 minus half to the power minus half, which is equal to 1 upon square root of 1 upon 2 is equal to square root of 2. Question 252 says that sum the series 1 plus 2 upon 6 plus 2 times 5 upon 6 times 12 plus 2 times 5 times 8 upon 6 times 12 times 18 up to infinity. So we proceed like previous problem and we get n is equal to minus 2 upon 3 and x is equal to minus half. So the series becomes 1 minus half up to the power minus 2 by 3, which is equal to 4 to the power 1 upon 3. Question 253 says that if y is equal to x minus x square plus x cube minus x to the power 4 up to infinity, show that x is equal to y plus y square plus y cube and so on up to infinity. So we are given this and we write that 1 minus y is equal to 1 minus x plus x square minus x cube and so on up to infinity, which is equal to 1 plus x to the power minus 1, which implies that 1 upon 1 plus x. So we have 1 plus x is equal to 1 minus y to the power minus 1. So x is equal to y plus y square and plus y cube and so on up to infinity. Question 254 says that show that the quotient of x to the power n in 1 plus x square to the power minus 1 is 1, 0, minus 1 as n is of the form 3m, 3m, 3m minus 1, 3m plus 1. So we can write that 1 upon 1 plus x square is equal to 1 minus x upon 1 minus x cube, which is equal to 1 minus x times 1 minus x cube to the power minus 1. Now it is trivial to prove what we need. Okay. Question 255 says that show that 1 upon e is equal to 2 times 1 upon 3 factorial plus 2 upon 5 factorial plus 3 upon 7 factorial and so on up to infinity. So Tn is equal to 2n upon n plus 1 factorial from this series. Okay. Now 2n plus 1 upon 2n plus 1 factorial minus 1 upon 2n plus 1 factorial is equal to this. Okay. So once we have that, that is equal to 1 upon 2n factorial minus 1 upon 2n plus 1 factorial. Let me see if there is something wrong. This should be 2n plus 1 factorial. Okay. This should be 2n plus 1 factorial. So once we have that, we can write that T1 is equal to 1 upon 2 factorial minus 1 upon 3 factorial. TR is equal to 1 upon 4 factorial minus 1 upon 5 factorial. So we have the series 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial, which is equal to e to the power minus 1, which is equal to 1 upon e. Question 256 says that sum the series 1 plus 2 square upon 2 factorial plus 3 square upon 3 factorial plus 4 square upon 4 factorial up to infinity. So here an term is n square upon n factorial, which is equal to n upon n minus 1 factorial is equal to n minus 1 plus 1 upon n minus 1 factorial which is 1 minus n minus 2 factorial plus 1 upon n minus 1 factorial. Now there should be an equality sign. T1 is equal to 0 plus 1 upon 0 factorial is equal to 1. T2 is equal to 1 upon 0 factorial plus 1 upon 1 factorial. T3 is equal to 1 upon 1 factorial plus 1 upon 2 factorial. So the sum of given series is 1 upon 0 factorial plus 1 upon 1 factorial plus 1 upon 2 factorial and so on, plus 1 upon 0 factorial plus 1 upon 1 factorial plus 1 upon 2 factorial and so on. That is E plus E is equal to 2E. Question 257 says that show that log of 2 is equal to 1 upon 2 plus 1 upon 1 times 2 plus 1 upon 3 times 4 plus 1 upon 5 times 6 and so on up to infinity. We know that log 1 plus x is equal to x minus x squared by 2 plus x cubed by 3 minus x cubed by 4 by 4 and so on. So log 1 plus 1 would be 1 minus half plus 1 upon 3 minus 1 upon 4 plus 1 upon 5 minus 1 upon 6 and so on, which is equal to 1 upon 1 times 2 plus 1 upon 3 times 4 plus 1 upon 5 times 6 and so on. Question 258 says that if y is equal to x minus x square upon 2 plus x cubed upon 3 minus x to the power 4 upon 4 and so on up to infinity, so that x is equal to y plus y square upon 2 factorial plus y cubed upon 3 factorial and so on up to infinity. So we know that log y is equal to this is equal to log 1 plus x, that is 1 plus x is equal to e to the power y. That is equal to 1 plus y square by 2 factorial plus y cubed upon 3 factorial and thus x is equal to y plus y square upon 2 factorial plus y cubed upon 3 factorial and so on. Question 259 says that if alpha beta are the roots of infinity x square, roots of the equation x square plus bx plus c is equal to 0, show that log of a minus bx plus cx square is equal to log a plus alpha plus beta times x minus alpha square plus beta square upon 2 x square and so on up to infinity. So alpha beta are the roots of the given equation, that is alpha plus beta is equal to minus b upon a and alpha beta is equal to c upon a. Now we are given that log of a minus bc plus cx square, that is we take a out, we get 1 minus b upon ax plus c upon ax square. That is log of a 1 plus alpha plus beta x plus alpha beta x square, which is equal to, we take a out here, we get 1 plus alpha x plus beta x. That is equal to log of a log of 1 plus alpha x plus log of beta x. So we evaluate the expansion, we get log a plus alpha x minus alpha x whole square upon 2 plus alpha x. This should be cube upon 3 minus so on. And this becomes beta x minus beta x whole square upon 2 plus beta x whole cube upon 3. Now we evaluate these two terms, we get log a minus alpha plus beta times x minus alpha square plus beta square upon 2 whole x square and so on up to infinity. Question 260 says that sum the series 1 upon 3 factorial plus 2 upon 5 factorial plus 3 upon 7 factorial up to infinity. So Tn is equal to n upon 2n plus 1 factorial is equal to half 2n upon 2n plus 1 factorial. We have earlier proven that 2n upon 2n plus 1 factorial is equal to 1 upon e when we sum this. This was question number 256, not 256, 255. So we have proven that, and in this case, sum of the series would be 1 upon 2e, right? Because half is here. So with this, we come to the end of question 260, and let me show you my website, astrologer.org. You can download the PDF of algebra, trigonometry, and connectivity from second, third, and fourth link. Note that when you download the PDF, this date will not be there, so you need to add the date to the PDF. Okay, and within 15 or 30 days, you should come back and check whether the PDF has been updated, and if the PDF has been updated, you should pause the video, you should download the PDF again and add the date again. Connectivity book is also available in HTML format. I would recommend Firefox to read it because the mathematics in this uses MathML and Firefox is best for MathML. Chrome and Safari do support. I think Edge also supports MathML, but still the math engine of Firefox is far more mature. So I would recommend you to use Firefox. Now, about the question answer website, you click the H link or come to kundika.astrologer.org. Here you can join the community which I'm trying to build and ask questions and answers of algebra, calculus, coordinate geometry, mathematics, probability, and trigonometry. If you ask any question, I'll try my best to answer your question. There are no guarantees that I will be able to answer the question. In general, you should use one of those tags, and if these tags do not cover, then we use the general tag of mathematics. So let's form a community where we can learn and share and grow the community and learn from each other. So with this, I will take my leave and we'll meet again tomorrow with 10 more problems on binomial, not 10 more problems. I think 7 more problems are remaining, 261 to 267, and we will finish this chapter tomorrow. And then we will move on to determinants after that. So starting on 7th August, we will have determinants. We'll finish this tomorrow. 7 more problems are remaining. So thanks a lot for watching the video. I hope that you enjoyed and got something to learn. So with this, I will take my leave and you have a nice day. Stay curious, keep learning, and most importantly, enjoy.